Hi everyone, welcome to another video with I Learn Engineering. My name is Leslie and today we're going to look at TCP IP and find out how it works, what it does, what it is and everything about it. So you've maybe heard people talk about TCP IP or you've maybe heard people talk about one part of it, so TCP or IP. It stands for, let me get my little text box here. So the TCP will stand for the Transmission Control Protocol. Nearly forgot how to spell protocol there. Oh. And then IP, it stands for the Internet Protocol. So that gives you a bit of a clue as to what TCP/IP is all about. It's a suite of communication protocols, and it can interconnect devices over the internet. So it could be the internet, as in the World Wide Web. It could also be a private computer network, such as an extranet or an intranet. And if you've ever worked in any kind of corporate type of company, a lot of the times they'll have an intranet, which is the internal company internet, if you like, and they can share different things with staff and stuff like that. So it can be used for those types of networks as well. And it will specify how data is exchanged over the internet. It provides end-to-end communication. So from my device to someone else's device, say yours. It identifies how the data should be broken down into packets, how it's addressed, how it's transmitted, how it's routed, how it's received at the destination. It's designed to make networks reliable. It has the ability to recover automatically from the failure of any device on the network. So it gives us a reliable way of sending data. So the TCP bit itself, it operates, so hopefully you've watched our video on the OSI model. If you haven't, go and watch it now. It operates at layer 4 of the model. It operates at the transport layer. So it ensures a reliable and orderly delivery of packets. So whenever we're sending data, it's split into packets, and it means that because they're reliable, it means that they'll get there and they'll get there in the right order as well. It manages how that message is assembled into the smaller packets before they're transmitted and then reassembled in that correct order. So it's a connection-oriented protocol, and that means it establishes a connection between me as the sender and you as the receiver, or vice versa, before it delivers any data. So that's what makes it reliable. It basically establishes that connection first. It doesn't just send the data out into the ether and hope that it gets there. It basically says, hey, I want to send some data, is that okay? And then waits for the receiving device to say, yeah, cool, send it, that's great. So it controls the size and the flow rate of data as well. It controls how fast it gets there. It deals with any kind of network congestion. So it deals with network traffic jams, if you like, which I think is a funny way of looking at it. So it means that anything that could block receipt of data, it deals with that. It sort of, let's say an example is that if I want to send a large amount of data to you over the internet, and the TCP part will break it down into the different packets, and it will say this is the order they have to go in. It uses one single request to send the entire stream of data, all the different packets. It will say what order they have to go in. It will say how you put them together when they get there and all of that. So we don't have to send a request for each packet that I'm sending. It just handles all of that, which is great. Saves us having to worry about it. It runs checks to make sure that the data is it runs checks to make sure that the data is delivered as well. It can detect any problems that arise in the IP side of things and internet protocol side of things. It can request retransmission of any packets that have got lost or anything like that. And we need all the packets to put together so that the receiving device has the full message, the full thing. So it will resend any that have got lost or anything like that. It can reorganize them so that they're sent in the right order, and that minimizes network congestion. So if you think that I'm sending your computer a message and all the data's broken down in the packets and all the packets are sent, if they're all sent in the wrong order, when they get to your device, then your device has to spend some time putting all the packets together in the right order, and that can cause bottlenecks in the network. So it minimizes that congestion where your device has to deal with, oh, I have to put them in the right order and I have to wait for them all to get here, because it sends them all in the right order. So that's TCP in a nutshell. Then we have IP, which, as we've said, stands for Internet Protocol. So it is what we call a low level Internet Protocol. I forgot again. So it facilitates the data communications as well. And both of these protocols work together over the internet. So IP will deliver packets of data that consist of a header. The header will contain the routing information, so where it's going to, where it's coming from, things like that. And it will also then have the data in there as well. And it defines how we address and route the packets to make sure that they get to the right place. And each computer on the network, so if we have a network, there's lots of different computers in the network, right? And each one will check, let me draw a very bad drawing. So if we have a network, and I'll just draw a couple of, imagine these are computers, okay? And this computer here, number one, wants to send some information over here, and maybe the information is going this direction, okay? So this machine will send data through. This second machine here will check and say, what's the IP address of that? Is that for me? No, it's not. Go on to this guy, he will check. Is that for me? No, it's not. Then number four, he'll check it. No, that's not for me, and he'll send it on. So each machine will, each device on the network will check the IP address and say, okay, I need to forward it over there. It's not for me, I need to forward it in that direction or that direction. So IP is limited by how much data it can send. So it's sending data in packets. Okay, if you think about little parcels, I guess. And each packet contains the header, which is where it's coming from, where it's going to. So it's the sending address and the receiving address. And it also contains the data. And it's limited to between 20 and 24 bytes. So that's not a lot, right? It's a small amount of data. So each packet is limited to that size. So if we have a lot of data, we have to break it down into all those different little packets, okay? And it's very limited then in how much can be put in each packet, and they all then have to be sent independently. So if we didn't have the TCP bit of this, all of these packets would just be sent, and there would be nothing to check that they're going in the right order. The IP side of things also doesn't check that there's a connection on the other end. It doesn't check with the receiving machine and say, hey, I want to send stuff. Are you ready? It just sends it. So the IP would just throw it out there, hope it gets to its destination, and it would just send it in whatever order. And IP also operates at, and if you've watched our OSI model video, hopefully you'll know what I'm talking about. It operates at layer 3. So TCP's layer 4, IP's layer 3. And that's the network access layer of the OSI model. So it's connectionless. It doesn't guarantee that delivery. doesn't provide any error checking, none of that. So it just sends things, and then TCP is the bit that kind of says, okay, we need to make sure these people are ready. We need to send it in the right order, and we need to check that it was all sent. So some of the common TCP/IP protocols you've maybe heard of would be HTTPS, so that's hypertext transfer protocol secure, FTP, which is file transfer protocol, or SFTP, which is secure file transfer protocol, or SMTP, which is simple mail transfer protocol. So there are some of the common kind of protocols that would use TCP/IP. And TCP/IP will use something called a client-server model of communication. So there's a user or machine, us, we're the client, and we want some kind of service. So we want to look up a web page, for example, or send a message or something like that. And there's another computer, a server. So we're the client, the other computer is a server. So if I want to load up a web page, as the client, I basically use TCP/IP to go to that server and say, hey, I want to load up this web page. I want to load up iLearn Engineering, right? And the server will then send everything back to me on my machine, and then it will load it up. So that's the client server model of communication. And TCP as a suite of protocols is classified as stateless. So each request I make is a new request. It's counted as not related to a previous one. So if I want to load up iLearn Engineering, their website, I send that request, and then I click on another page, and it treats that as a brand new request and loads that again, and that kind of frees up those network paths. So I think we should be able to do it here. So if I go to ilearnengineering.com, this is my first request, and it gives me the information back. So I'm the client, and I've said, I need this, and here it is. And then it drops that connection. It says, right, she's got her thing. I can go off and do my own job now. And someone else can use that network path, another machine. So someone else wanting to load up iLearn Engineering or do something else, they can use that same network path. I'm dropped. Now say then I want to click on something. I go, oh, the free learning resources. I'll click on that. This is a new request. And it returns the information to me, and then it drops that again. That's what that means, basically. That's what we mean by stateless. And then if I clicked on something else, that's a new request. And each time it drops the request, and someone else can use those network paths. If it kept my request open until I'd finished, I would be using the same network paths to click on all the different links here, to go to do something else, and that means that those network paths are kind of held just for me, and that's not as efficient, right? So that's what we mean by stateless. And with the TCP/IP model, it differs from the OSI model. So we talked earlier in another video about the OSI model, and it has 7 layers. The TCP/IP model doesn't have as many. So the TCP/IP